Good day, students of Algebra 2. This is Mr. Hotard here, and yes, this is my real face. This is what I look like without a mask. Now, if you're watching this video, hopefully at this point you have already tried that bell ringer activity that I posted in Google Classroom, where you had to label each graph as a certain type of function. If you haven't already, I want you to pause this video, try it out right now. Don't worry, I don't expect you to get all the answers right. I just want to see what you remember. So try it out, check your answers. All right, did you do it? Okay, wonderful. So that right there was a quick synopsis of all the different types of functions we'll be learning about in Algebra 2. Today specifically, we're going to be learning about linear, constant, absolute value, and quadratic functions. I know you're excited, so let's get started. Okay, by the time we finish this lesson today, the video and the practice that goes with it, there are two things you should be able to do at that point. You should be able to A, classify a function as linear, constant, absolute value, or quadratic based on its equation or its graph. And then second half, B, you should be able to also identify what's called transformations on the parent function. Basically, if you have extra numbers in an equation, what do those numbers do to the graph of that equation? So let's just start with the types of functions. Let's start with the one you should be most familiar with, linear functions. Now, what word do you see in linear? See line, all right? Linear functions make a straight line. Now, the equation of a linear function, a lot of y'all are thinking, oh, I know that, y equals mx plus b. That is correct. That is the slope-intercept form of a linear function. All right, you did that a lot in Algebra 1. Now, I'm going to change things up in the formula a little bit. You're going to see why in a minute, but any linear function can be written like this. Y equals, instead of m, I'm going to use the letter a, all right, just so that I have the same letter I'm using with every formula. And then parentheses, x minus h, close the parentheses, plus k. So you can have some number in place of a, some number in place of h, and some number in place of k. Now, yes, if you had that, you could simplify it out, change it into slope-intercept form, but for now, we're just going to stick with this formula. Now, what's the parent graph equation? If I didn't have any numbers in place of a, h, or k, if I just had a linear function with no extra numbers, that would be the parent equation, or the parent function. When I was in high school, my teacher called it a mother function. You can imagine the fun we had with that. Everybody started calling things a mother function. But anyways, the parent function, if I had no extra numbers for a linear equation, would just be y equals x. Now, the graph of that, right, you recall it's going to make a straight line. Y equals just x would start here at the origin at 0, 0. And then if you remember slope, it would go up 1 over 1, up 1 to the right 1. All the way across the graph. And same thing this way. It would go down 1 to the left 1. So that parent function of a linear function is just straight line, y equals x, going through the origin, up 1 over 1. That's a linear function. Now, a special type of that is called a constant function. If instead of having several numbers in the equation, if you just had y equals some number, y equals, we'll call it k. All right, k can be any number. That's a constant function. All right, so parent graph of that, if I didn't have any extra numbers, would just be y equals 0. So that, it would be a special type of line. It would be a horizontal line going through that number. So the graph of this would be a horizontal line going through 0, 0. So it would basically just be a line right on top of the x-axis. That's the parent function of a constant function. Now, it's not always going to go through 0. It could be y equals any number. If it had been y equals 1, it'd be a horizontal line going through the 1. All right, so that's linear and constant. Now, the other two functions are a little bit more complicated. All right, next one, absolute value function. First of all, do y'all remember what absolute value is? Absolute value is those bars that sometimes appear in a problem. So something like this, absolute value of -2. Now, do you remember what the absolute value of -2 is? It's +2. Absolute value is asking about the distance from 0. So absolute value of negative 2 is 2 units away from 0. Same thing if I asked you what's the absolute value of positive 2. That would also be 2. All right, absolute value always spits out a positive answer. All right, so absolute value equation would look like this. Be y equals some number a, absolute value bar, x minus some number h, close the absolute value bar, plus k. All right, that would be my absolute value function. Any absolute value function could be written in that form. So again, if there weren't any extra numbers in here, the parent function would just be y equals the absolute value of x. Now, what would the graph of that look like? Well, let's figure this out. So if I just plugged in some numbers for x, so for example, if I plugged in 0 for x, what's the absolute value of 0? It's 0. So I'd have the point 0, 0, starting at the origin. If I plug in 1 for x, absolute value of 1 is 1. So I'd have the point 1, 1. If I plug in 2, absolute value 2 is 2. So it looks like it's making a straight line. All right, it goes up and over, just like a linear function. But what happens if I plug in a negative number? Absolute value of negative 1 is what? Positive 1. All right, so I'd have the point negative 1, positive 1 up here. And then if I plug in negative 2 for x, absolute value of negative 2 is positive 2, right here. And then negative 3, 3, so on and so forth. So this winds up making a V shape. How exotic. All right, so absolute value functions, if they have those bars, they always make a V shape. If you just remember V for value. And then the last type of function we're going to look at today is called a quadratic function. You may recall from Algebra 1 quadratic functions, they always have a little 2 exponent in them, something squared. That makes it quadratic. So the formula for a quadratic function would be y equals a parentheses x minus h, close the parentheses, squared plus k. All right, you can have some number in place of a, h, and k. Will give you a quadratic function. Again, it's quadratic because it has that 2 exponent in it. All right, so if you had no extra numbers in the problem, the parent function would just be y equals x squared. Now, what shape would that make? Well, it's going to make what's called a parabola. All right, because if I try to plug in numbers for x, so for example, if I plug in 0 for x, what's 0 squared? 0 times 0 is 0. So I have the point 0, 0 right here at the origin. If I plug in 1 for x, 1 squared, 1 times 1 is going to be 1. If I plug in negative 1 for x, negative 1 squared, negative 1 times negative 1, would that be negative 1 or positive 1? It'd be positive. Negative times negative is a positive. So I have negative 1, positive 1. So it looks kind of like absolute value, but it's not going to keep making a V, because what happens, for example, if I plug in 2 for x, 2 squared would give me 4. So I have the point 2, then 1, 2, 3, 4 right here. And then same thing if I plug in negative 2 times negative 2 would be positive 4, 2, 3. So I'd have negative 2, 4. It makes a U shape. It makes a parabola. So main things to remember so far, if you're seeing these bars, absolute value bars in the problem, it's going to be an absolute value function. It's going to make a V shape. If you're seeing some kind of squared, a 2 exponent in the problem, it's a quadratic function. It's going to make a parabola, a U shape. If the problem has neither of those things, then it would be linear. It would make a what shape? It would make a line. And then a special case of linear, if it's just y equals some number, that's a constant function. That would be a horizontal line. All right, so at this point, you should have a worksheet that I gave you in class that I also posted on Google Classroom. All right, it's probably on the back of these notes. But I want you to right now pause this video and try to answer questions 1 through 8. Just classify each one of those. Try to do it without looking at your notes. See if you can do it from memory. And then if you need the notes, use the notes. Did you do it? Great. All right, so the last thing we're going to look at today, part 2 of this, is transformations of these parent functions. If you look down at the bottom where it says summary, all right, you notice each of these equations we've worked with, they have the same 3 letters in them. They have an A, an H, and a K. Each of these values does something to the parent function. It affects the graphs. All right, so I want to talk about what these 3 things do. And actually, I want to start at the end. we're going to look at the k value first. So let's just start with the function that you're most familiar with linear functions. If instead of graphing y equals x, if I ask you to graph y equals x plus 2, do you remember what that plus 2 at the end of the equation would do to this graph? Instead of starting at 0, 0, it would start here at 0, 2. It'd shift the whole thing up 2. So the k value, I want you to write this down, the k value in the equation, at the end of the equation, it's either going to shift, it shifts the graph up if it's a plus, or it'll shift it down if it's a minus. So if you have a plus 7 at the end of any equation, not just linear, but any of these functions, if you have a plus 7, that would move the whole graph up 7. Minus would move it down. Now, the k value at the end moves it up and down. What do you think the h value on the inside of the absolute value, or the inside of the parentheses, what do you think that would do? It would move it left and right. All right, the only thing is, it does the opposite of what it looks like it should do. A lot of people, when they see absolute value of x minus 3 here, they think, okay, minus 3, negatives on the left side, so it's going to move it to the left. That's not correct, all right? A minus 3 would actually move it to the right. A plus 3 moves it to the left because you notice the formula already has a minus in it. So if the problem says x minus 3, it's really x minus a positive 3. All right, so basically what that means is it does the opposite of what it looks like it should do. The h value, it's going to shift it left if there's a plus, or it's going to shift it right if there's a minus. So if there's an x minus 5 in the parentheses or in the absolute value, that will move the whole graph to the right. Something plus something inside the parentheses will move it to the left. And then the last thing, the a value, all right, if we go back to our linear function, all right, we used a, in Algebra 1, you probably used m. Do you remember what m told you about the equation? It was the slope. And all of these, you could think of that a value as the slope. All right, or the rise over run. Okay. Now, what does that mean for the actual transformations? Well, it does several things. All right, first of all, so for example, if you look at the linear one, right now there's an automatic 1 right here if they don't put a number. But let's say instead of a 1, I had a 2. So this graph will go up 2 over 1. All right, still start here at 0, 0, but it'd go up 2 over 1. It would stretch it out. All right, same thing with the absolute value. Like instead of having a 1 for the slope, if I had a 2 for the slope, it would stretch it. It would make it thinner. All right, so main things to remember here, again, for the a value, it is the slope, but as far as what are the transformations, it would be a vertical stretch, if you have a whole number, any number bigger than 1. Now, if it were a number smaller than 1, if you had a fraction for your slope, basically instead of looking like this, the line would get flatter. We call that a vertical shrink because it's shrinking it down toward the x-axis. So vertical stretch, if there's a whole number, all right, it would be a vertical shrink if you have a fraction. Now, I'm being kind of general here. There actually are fractions that would be a vertical stretch. Can you think of a fraction that would be a vertical stretch? It'd be something like 3/2 or 5/3, something like that. Basically, if it's bigger than 1, it's going to stretch it. If it's smaller than 1, it's going to shrink it. And then one other thing that can happen, all right, sometimes you could have a negative in front. If that a value is a negative, what do you think a negative in front of the equation would do to the whole graph? It would flip it over. So one other thing, and I want to just make sure we're including this in the a value, so you might want to just draw a line here so you don't get separated. But if you have a negative number for the a value, all right, in that case, we call that an x-axis reflection. X-axis reflection. Or you could just say it flips over. It's upside down. But the official term is x-axis reflection. All right, so for example, if I had, let me just write one example down at the bottom. All right, so for example, if I said I had y equals, say parentheses, x minus 3 squared plus 2, and let's say I also had, let's say I had a 4 in front of it. All right, so just talk about what would these things do. Which way would the plus 2 at the end move the graph? It would move it up 2. Which way would the minus 3 in parentheses move it? It'd move it to the right 3. Now, what about the 4 in front? Would that be a vertical stretch or a vertical shrink? It'd be a vertical stretch of 4. Would there be an x-axis reflection here? No, because it's not negative. So if you had this problem, if I were asking for the transformations, you'd tell me vertical stretch of 4, you'd tell me it shifted to the right 3, and you'd tell me it shifted up 2. Those would be the transformations. So on that worksheet, it asks on the bottom half to list the transformations. These are the things you would list for that specific problem. All right, if there's a negative in front, you'd also say there's an x-axis reflection. But that didn't happen here. Okay, so good luck. Try those problems. I will see y'all in class next week.